In this question, we have to find out SRP, standard reduction potential of conversion of Cu plus 2 to Cu. We have to find out SRP of Cu plus 2 to Cu. So its volt SRP is given x volt, and we have to find out the value x, as well as we have to also find out whether the conversion of Cu plus in Cu plus Cu plus 2 is feasible or not. It means Cu plus can disproportionate or not. We have to find out these two questions. So it's very simple. First of all, we can write down the reactions. In first reaction, we can observe that Cu plus 2 gets converted to Cu plus, and E naught is given as plus 0.15 volt. In second reaction, now here we have one electron we have to add, then Cu plus 2 will convert into Cu plus 1. In second reaction, we can observe Cu plus is getting converted into Cu. Again, we have to add one electron here in reactant side, and E naught given is at 0.50 volt. 0.50 volt, and we have to find out E naught for this reaction. Now we can observe it is the first reaction and it is a second reaction. If we will add first and second, then we can get this reaction, means that is the third reaction. So we can get third reaction, means our third reaction is the sum of first plus second reaction. So according to thermodynamic principle, if we calculate the delta G naught of this reaction, that is equal to delta 1, and for second reaction delta naught 2, then the delta G naught 3 of third reaction will be equal to delta G naught 3 will be equal to delta G naught 1 plus delta G naught 2. Now we all know that delta G is equal to minus NFE cell, and delta Z naught is equal to minus NF E naught. So if we will substituting the values of delta G3, delta G1 and delta G2, then we can get that delta G1. First of all, we have to calculate delta G1. That's very simple, means that will be equal to minus N. What is the value of N? That is 1, number of electron at F. F is, we can put as F or 96500. And what is the value of E naught? That is 0.15. So our delta Z naught 1 will become, 0.15 minus 0.15 Faraday. That will be delta G naught 1. Now we can calculate the delta G naught 2. What will be the delta G naught 2? That is minus NF E naught. So value of E naught again, that is 1, and F E naught in second reaction is plus 0.50. So our answer will be like that, minus 0.50 Faraday. That is our delta G2. Now delta G naught 3, which we have to calculate for our third reaction. The reaction of question means it is asked, so it will be equal to minus n. Now we can observe what is the value of n. Value of n is here 2, means 2 number of electrons are involving. So that will be equal to 2 into F into E naught 3. E naught 3 we have to find out. So if we will substitute these values in this equation, then ultimately we will get E naught 3 is equal to, that will be equal to plus 0.325 volt. We have to substitute these delta G1, G2 and delta G3 value here, and we will get delta E naught 3. That will be our answer, means first answer. So E naught 3 will be plus 0.325 volt. For second question, means second part of the question, in which we have to find out whether the reaction will whether the Cu plus disproportionate or not. We have to calculate first Cu plus when gets converted into Cu plus 2, then it will release one electron. Hence here delta G naught 1 will be equal to minus NF E naught 1. So it will be equal to minus n, value of n is 1, and now F is like F Faraday 96500 and E1, because we are inverting our first reaction. We are inverting our first reaction, means in first reaction that was given Cu plus 2 when gets converted into Cu plus 1. When Cu plus 2 gets converted into Cu plus 1, then the electrode potential is plus 0.15. So if we are taking opposite reaction means when we are converting Cu plus to Cu plus 2, then electrode potential will be minus 0.15. So here we have to find out minus 0.15. Now our delta G1 will be equal to minus, that is equal to, it will be equal to minus plus, so that is equal to plus 0.15 Faraday. Similarly, we have to calculate the delta G for the reaction. That reaction is del Cu plus 1. Cu plus 1 when accepting one electron, getting one electron, it gets converted into Cu. So here delta G2, or we can say delta G naught 2, is equal to minus NF E naught 2. So delta G2 will be equal to minus 1 into F into Faraday's constant is 0. Faraday constant 96500. We are putting just as like as F, and E naught 2 is 0.50. So our delta G naught 2 will be equal to minus 0.50 F. If we add our first reaction and second reaction, now which one is our first reaction? That one is our first, and that one is our second. So this reaction is first reaction, and this reaction is second reaction. So now if we add first and second both reaction, then we will get a new reaction. That reaction is 2Cu plus is equal to Cu plus 2 plus Cu. So the delta G naught of this reaction means delta G naught 3, because we are adding first and second reaction, that's why it will be equal to delta G naught 1 plus delta G naught 2. So if we will solve it, then E naught 3 for this reaction will be equal to delta Z naught, means that will be equal to plus 0.35 volt, because E naught is coming for this reaction as a positive value. That's why we can say this reaction is spontaneous. This reaction is spontaneous, means we can say Cu plus 1 can convert into Cu plus 2 as well as can convert into Cu. So that is the definition of disproportionation reaction. So what is the disproportionation reaction? If same element oxidation number is increase as well as oxidation number is decrease. So oxidation number of Cu plus 2 is plus 2, and in Cu, that is in elemental state, oxidation number of Cu is 0. Here oxidation number of Cu plus 1 is plus 1. So means Cu plus 1 is getting oxidized as well as getting reduced. So we can say yes, Cu plus 1 can disproportionate, because delta E naught 3 for this reaction will positive value. It is positive value. So if we calculate delta G3, so delta G3 G naught 3 will negative. So this reaction is spontaneous reaction. So we can say yes. Cu plus 1 can disproportionate into Cu plus 2 and Cu.